Good morning and good afternoon for those of you in various time zones. Welcome to CUIIC Academy's Underground Infrastructure Education Webinar Series. My name is Mark Murphy. I'll be moderating this event. People are still signing in. So again, thank you for joining. This is the third webinar series, third in the webinar series. Today's topic is spray-in-place pipe, spray-applied systems for trenchless rehabilitation, presented by Sanaz Ghalambor, who's the Vice President of Specifications for Nukote Coatings. My name is Mark Murphy. I work with Empipe. We are a proud sponsor of both CUIIC and to be a sponsor of the 2023 CUIIC Academy Webinar Series. Please contact Hannah Stakolich for more information on becoming a sponsor. As a sponsor, we have been given the ability to increase our notoriety throughout the trenchless rehabilitation industry, and you as a sponsor will benefit from that too. Who is Empipe? Empipe is a full-service water wastewater infrastructure company. We do inspection, we do repair, we do rehabilitation, and we do spray-in-place pipe. We have a fleet of trucks that range from pumper trucks to CCTV repair, as well as our spray-applied coatings trucks that can both prepare and rehabilitate the surface. And we have recently been working with robotic applications, which is going to be discussed in this presentation. Robotic applied applications not only will give you a more evenly applied coating, but it will also allow you to save money versus other technologies such as HDPE, as well as improve your safety on site, because you will not need to do manned entry into buried pipe. The CUIIC Academy webinar series slide, the CUIIC Academy webinars cover a variety of pressing topics related to the underground infrastructure sector. Speakers include industry-leading professionals who will provide a monthly free educational webinar to the public, followed by a question and answer period, held on the third Thursday of every month at 1 p.m. Eastern Standard Time. CUIIC Academy, please join us next month on April 20th for our Microtechnology for Utility Installation webinar, presented by Kevin Jolly, National Business Development Manager for Duraline. For more information on the events listed, please visit the Academy, visit academy.cuiic.ca. Sanaz Ghalambor is attending as a guest speaker on behalf of IMC Distributors. Sanaz is Nukote Coating Systems Vice President of Specifications and is a professional in structural pipeline rehabilitation utilizing SIPP and SAPL structural lining systems. Sanaz is also a voting member on the American Waterworks Association's Committee M28, M81, and a lead of the publication subcommittee of the C260 appendix. Sanaz is currently completing her PhD in civil engineering and holds her bachelor's degree in polymer engineering, as well as a Master of Business Administration. Along with her decades of experience working with polymeric coatings and liners, Sanaz is an expert in this subject matter. I now welcome Sanaz to the presentation.
Thank you so much, Mark. Good afternoon, everyone. Our presentation today would be about SAPL or SIPP. We are going to cover the reasons why rehabilitation is needed, about the methods available for pipeline repair, renewal, and replacement, specific trenchless renewal methods. We are going to introduce spray-applied pipe liner, advantages, different types, using this technology for pipe rehabilitation and renewal. And we are going to cover SAPL installation, evaluation, and testing. Pipes, culverts, drainage infrastructure, including storm sewer, culverts, are an integral part of departments of transportation and municipalities' assets, and they routinely require inspection, maintenance, repair, and renewal because they get deteriorated over time. Failure to these conduits is costly due to emergency cost of replacement and also due to social cost of traffic interruption and inconvenience to the public. The deteriorated culverts need to be repaired and renewed or replaced. Culvert replacement can be done by open cut method, which is usually costly as it is associated with indirect costs that typically left to be borne by society, as it involves traffic delays and detours. Based on the type of the work, this method is also called dig and install, dig and repair, or dig and replace. So this method is not popular, or it's not possible in many cases. That's why we need to switch to trenchless technologies. Renewal or rehabilitation of pipes, culverts using trenchless technologies is most cost effective. It is environmentally friendly, and it has low social impact compared to open cut, replace, or repair methods. There are different trenchless renewal methods available, including slip lining, CIPP, spiral wound lining, close fit, or spray-applied pipe lining, including cementitious and polymeric. Among existing trenchless culvert renewal methods, spray-applied pipe lining, or SAPL, can utilize a special technology for renewing the old pipes and culverts. And in this technology, we can use either cementitious or polymeric materials for both partially deteriorated or fully deteriorated culverts. And these technologies can be used in corrugated metal pipes, CMP pipes, or RCP pipes, or any other different types of pipes. Among these methods, SAPLs can provide more flexibility in installation, specifically for tight-to-reach areas. This technology has higher speed of mobilization and installation and less social cost. In the presentation today, we are going to mainly focus on polymeric SAPL, not cementitious. So we're going to introduce spray-applied pipe lining. Development and the use of coatings was to increase infrastructure life expectancies because of accelerated corrosion problems in the industry and infrastructure, and greater awareness of corrosion issues. So that's when coatings came to the market. Because of the water quality issues in the cement mortar lining and the profuse water leaks through the cracks, water bodies around the wall started looking for something to substitute these cement linings, and they concluded that polymeric SAPL would take care of most of the problems that they were dealing with. Among the polymeric lining shortlisted, the three polymers that stood out in the final analysis because of their physical and mechanical properties were epoxy, polyurethane, and polyurea. These polymers are two-component, combined resin and hardener, which are in a liquid state until they are combined and allowed to chemically react. Once the reaction is complete, they will turn to 100% solid. So we spray a liquid material inside the existing pipe directly to the substrate, and in a few seconds, it gets dry and it makes a new polymeric pipe inside the existing pipe. These polymer linings are not applied by conventional methods like brush or roller, or even conventional like airless or air sprayers. We need to have dual component air sprayer systems because these polymers or their reaction is very fast. So the pot lives are very short. That's why we need specific equipment to spray those. Compared to cement mortar linings, these polymers have better tensile and bending strength without need of additional reinforcement. And life expectancy of these polymer linings have been lab tested and can prove that they can have high life expectancy. Okay. So what is SIPP or SAPL? SIPP or spray-in-place pipe is another name for SAPL or spray-applied liner. These systems are also known as spray-on linings or underground coatings and linings, UCNL. But we usually use term of SAPL or SIPP for this technology. SAPLs are different from conventional coatings because coatings are considered as barriers for corrosion protection, but linings are used for both corrosion protection and structural enhancement. SAPLs are applied in layers, so we apply layers of the liner on the interior surface of the hose pipe to provide a new polymeric pipe and provide corrosion protection and also structural capacity enhancement. This technology is very safe. It has very good performance, very quick installation, and back to service. So it can go back to service almost immediately. It is solvent-free, no VOC, so it's a perfect solution and very safe in confined spaces. It has proven to have unique advantages for successful renewal and corrosion protection. And this technology is based on thermoset coatings or linings or inert plastics. So when cured, it is resistant to most corrosive elements. Polymeric SAPL is applied directly on the substrate, so it doesn't leave any annular space, annular gap between the new polymeric pipe and the hose pipe. It is seamless, jointless. It can enhance the structural strength of the hose pipe. It can maintain or improve the hydraulic flow capacity of the pipe, and its thickness and quality of the SAPL material can provide the greatest flexibility for design because the system is not prefabricated. So we are not inserting a new pipe inside the pipe. We are spraying a new pipe inside the pipe. So we can continue spraying layers and layers until we get the required thickness and go from there. That makes the whole thing much easier for us. If we want to compare it with other technologies, to compare it with like slip lining, which requires heavy vehicles to transport the slip line segments, hydraulic jacks or backhoe to slip line the liner. SAPL only needs a portable ordinary air compressor and a medium-sized mixer, and all of these can go into a small truck, so very small footprint. And comparing to CIPP, it doesn't need large amount of pressurized water or to be installed or boiling system to be cured. Actually, curing process is not separate from installation. So when we spray the liner, as soon as it is in contact with the substrate, it starts getting dry and cured. So no separate step for curing. It is environmentally friendly, chemical resistance, and it can be applied very fast. So when the pipe is lined with polyurethane or polyurea SAPL substrate, which can be concrete or steel or whatever, can be submerged, buried, or driven as soon as we get to the tag-free time. So very fast back to service is possible with this technology, which makes this technology very unique. Polymeric SAPL in pipe rehabilitation and renewal can be used in different stages of the pipe lifetime. So when the pipe is new, when manufactured or just installed, we can apply the system inside the pipe, fully bonded in very thin layers to protect the pipe against corrosion and deterioration. So we can apply non-structural corrosion prevention only. If the pipe is in a good shape, if it can carry the live load and dead load, but it has some leakage or pinholes or cracks, we can use this technology for semi-structural pipe rehabilitation to prevent ingress and egress of water. And also in the cases that the pipe is very old, it has lost its structural integrity, it is not in a good shape, we can apply the system to renew the pipe, so to make a new polymeric pipe inside the pipe so that it can extend the lifetime of the pipe for another 50 years minimum. So this system can be used in different classes from non-structural to full structural, depending on the condition of the pipe and project specifications. So this polymeric SAPL can be used for pipe renewal and rehabilitation in gravity lines and also pressure lines, for lateral renewal, for manhole renewal, as a pipe coating or lining, as internal lining and external coating, for anti-corrosion, semi-structural and full structural systems. This technology is compatible with complex geometries, so different shapes of pipe, circular, horseshoe, box culverts, arch pipes, all of those this technology can be used in all of those. And there is no need for lateral reconnection. It has less construction space needed, so low construction cost, and it prevents pipeline internal corrosion, erosion, abrasion, and further deterioration. It can be used in potable water, sewer, wastewater pipes, culverts, transmission lines, and reservoirs. Let's talk about polymeric SAPL installation. There are three main methods to apply or install the system. For larger pipes or the pipes that have irregular shape, we can do it manually, so we can spray it manually. For other cases, for 30-inch and above, up to about 21 feet, we can do it robotically. And for small pipes from 4-inch and above, we can use spin cast unit to spray the system. We are going to watch a couple of videos here. I'm sorry, I could not talk over the video. So what you watched was application through spin cast unit, manual spraying, and also installation using the robot. So the robot is, it can rotate 360 degrees. It can move forward and backward, and all the speed of crawler and RPM can be adjusted based on the diameter of the pipe or the thickness needed in each layer. As mentioned before, the system should not be or cannot be used with regular methods like using conventional sprays or brush or roller. So this is the system that we use, the reactor or proportionate unit that we use to apply the system. And because the reaction time is very fast, the A component and B component or resin and hardener should be kept separately until they mix right in the gun at the nozzle. And as soon as they are mixed and sprayed, they get gelled and they get dry in a few seconds. And that's why we can keep spraying and getting the thickness without being concerned about having sagging, or we don't have to wait between the layers so that we get to like tack-free time of the previous layer so that we can apply the next layer. It's not like other traditional coatings that we have a window time between the layers, and that's a benefit about the system. As mentioned before, it has a very small footprint because everything, including the robot, the material and totes, the pump for spraying, and also power supply, air supply, all of those can go into a small truck or a trailer, and that's the whole footprint needed. So we don't need to make like new shafts or dig into the ground, or none of those. So we can use the access points available, and that is the whole space that we need for the system. The rest of the things would be done underground. If we use the robotic system, the only thing that goes inside the pipe would be the robot, and everything can be controlled from outside. Using the robot, it actually provides true efficiency because of reduced cost of labor and also material. As you see in the graph, it shows that the consumption by using the robot would be about 23% lower. So it actually has lower loss factor. So we need to consume less material in getting the same thickness with robot and without robot. So, and also you can see that the uniformity of the liner or the thickness would be much better using the robot. We have done several tests, studies, research, and evaluation processes to see if the system can be used for pipe rehabilitation and renewal and to which grade. I'm going to only address some of those. Hundreds of tests that have been done, but we really don't have enough time to go over all of them. One of the important tests that we have done in Paragon Lab in Canada and also NetPep AASHTO was parallel plate compression test. This test determines the pipe stiffness, which is a function of pipe dimensions and also physical properties of the material. As you see in the picture, that section of the pipe is just a polymeric pipe. It doesn't have the hose pipe with it. So all the load will be applied on the SAPL or SIPP pipe. So in this test, we wanted to see how the liner performs under a 5% deflection. This was done with no cracking, no breaking. So we continued up to 10% and finally to 15% of deflection. Again, no cracking, no nothing. It shows that this system has very good ductility, although it is very hard and strong. It has enough ductility and it is not brittle at all. So it can go up to 15% deflection without breaking and cracking. Another important study that has been done was structural evaluation through soil box test. For this test, we have done the test in different pipe shapes, including circular and arch pipes, and different sizes of the pipe and different thicknesses of the liner. So we did this test in 3 series. And the proposed was to evaluate the structural capacity of polyurea SAPL. It is very important because we want to use this for structural renewal and enhancement of the pipe. So we wanted to make sure that this system can be used as a standalone pipe within a pipe without relying on the hose pipe. I can carry all the loads needed. So the testing was conducted on fully deteriorated CMP pipes. That by fully deteriorated, I mean they had no invert. The inverts were caught and they were preloaded. So the crown was already buckled. We applied the liner inside the pipe. The soil pipe system was subjected to vertical static live load, which was applied through a 330 kips hydraulic actuator to simulate AASHTO H20 truck service load. We did this test, and I want to show you a video here. Would you please run the video? So we continued loading until the failure happened. The failure or the ultimate load or cracking load was reported. The failure was because of cracking on the crown of the pipe, only longitudinal cracking, no circumferential cracking. And the results were very impressive. In this picture, you see what I mean by not having an invert. So the invert was caught so that we can simulate the fully invert deteriorated pipe. So the results were very interesting. According to the AASHTO LRFD, the calculated pressure on top of a flexible pipe due to the H20 truck service load is 13.75 kips. All the numbers that we got for the cracking load and ultimate loads were higher than that 13.75 kips, even the lowest thickness, which was 1/2 inch only. And this test showed that this system can be used as full structural in these applications. Punch shear test is also a very important test because the pipe and liner system need to resist the sudden load, shear impact, for shallow depth culverts and pipes, and the impact of any rock if present. So as you see, the results were very impressive. The results were much higher than pipes like HDPE that are being used as a new pipe for pipe replacement. I should go faster. So we have also done the tensile flexural long-term, short-term and long-term test to predict the strength of the material and dimensional changes under long-term loads, and materials long-term performance extrapolated for 50 years, because we design our system for 50 years. And these are polymers, they go through CUIIC. We want to make sure that our system can last for 50 years. So the values, the numbers, the properties that we use to design the pipe should be the numbers after 50 years, not the numbers for the short-term testing. We also have done internal pressure burst test based on ASCMD 1599 to determine the resistance of the liner material to hydraulic internal pressure. And also we have done internal pressure hole spanning test with hole size of ½ an inch up to 6 inches. And the pressure, maximum pressure that the lab could go for was 600 psi. So all the samples could pass the test up to 600 psi with no failure. And we kept those pipes in that high pressure for 10 days without any failure and issues. Also, we had done vacuum tests, vacuum pressure resistance at 24.6 inch of HT in the cases that our pipes would be depressurized and go to the vacuum phase. We also have done hydraulic flow capacity test to make sure that our system would maintain or even improve the hydraulic flow capacity. And if possible, please show this video as well.
Oh, push it down, stand on the back end, get that right draw. Push it over through the robot. Yeah. Oh, that's reaching now.
So as a conclusion, polyurea, polyurethane SAPL can be applied on any substrate, almost any level of deterioration, any shape. So any shape, any size, any diameter, any length. It needs no excavation, no entry-exit shaft to be made. And it needs smaller working space. It is great for full structural, semi-structural, and anti-corrosion rehabilitation. It can be applied direct to the substrate, and no grouting is needed. And installation can be done from manhole to manhole or bale holes, reducing excavation. Sorry, I had to go very fast on the last slide to keep the time. If there is any questions, we'll be glad to answer.
Well, thank you, Sanaz, for that great presentation. Actually, quite a few questions came in while you were speaking, and the one that I was expecting was, how does this compare to CIPP?
Okay, so I think I already addressed it in one of the slides. So different things. Usually for CIPP, we are dealing with applying the system, installing the system, and then a curing phase separately. So we don't have a separate curing phase for this technology. Also, we usually install the system in CIPP and then send the robot to interstate and like do the laterals. We don't need to do that for this one. Everything can be applied direct to the host pipe. Wherever we don't need to apply a liner, we stop application. So application would be faster and return to system to service actually would be faster. Also, the system is not prefabricated, so for any shape, any size, we don't need to order it in advance to know that like this is the size or shape that we need. We can just spray the liner inside the existing pipe, existing shape with no limitation. These are the main things about it. Also, we have some issues with having styrene in the system for CIPP polyester type, which we don't have it for SAPL. It is VOC-free, solvent-free, styrene-free, coal tar-free.
Great. My apologies, I forgot to introduce my partner here in Canada, Aidan Logan from IMC Distributors. He has been answering some of the questions already online, but there are several more. Aidan, are you there?
Yes, I am here. Just typing away.
Great. So yeah, there's several questions that are coming in about design thickness and the use of F1216. What I know that you use a different system. Can you give a little bit of an explanation on that?
We use different ways to design the liner thickness. So one of the methods is following F1216 equations for partially dehydrated and fully dehydrated. But on the tests that we have done it, all of them showed that following those equations would give us too much of over design, because, for example, in one case, we did the design based on F1216, and the required thickness for fully dehydrated was 2.5 inches, although we could get the pass result with 0.5 inch. So that is not a perfect way to do it. We are working on the design appendix for AWWAC 620. Hopefully when we have that ready, we're gonna have our own equations for SIPP. The other ways that we do the design is using a Candy software, culvert analysis and design, and also we model the pipe using Abacus or SAP 2000. So we model the pipe in the existing condition, depth of bury, the loads that are applied on the pipe, and we check the loads, including the live load, dead load, internal loads, vacuum loads, whatever, hydrostatic loads, compare those with allowable stresses based on the material properties, and we do the design based on those, checking the maximum deflection. So these are the main ways that we do the design for SAPL.
Aidan, are there questions that you feel the group would benefit from that you've already answered?
I made most of them public. Sanaz did speak to the one with the CIPP. I will say I do see a lot of questions pertaining to the strength testing, as well as the long-term creep test and the short-term values. So I will say we're more than happy to share the test reports with you afterwards as well, if we can reach out. As well as I see a lot of questions pertaining to the wearability and abrasion resistance of the materials. I will say if you review our products, they are very abrasion and wear resistant. Some of the products we do utilize in the oil sands, as well as the mining industry, for slurry and tailing pipeline coatings as an internal liner. So we're more than happy to discuss this with you, as well as share the information afterwards if we are able to reach out.
Great. A couple of the questions have come up to ask, can it be applied to a wet surface? Sanaz,
yes, I've seen that quite a few times. So what we will say is when we are doing a full structural liner, where we aren't looking for adhesion, we want to be tight to the surface but not adhere. We don't need the substrate to be completely dry. We can't have active water flow, and we have to stop inflow and infiltration, but residual moisture is not an issue. In a case where we're doing an anti-corrosion system, so non-structural, we're just trying to protect and be preemptive for a new or in good condition asset, then in that case, we would want to dry the substrate just for adhesion purposes. My apologies, Mark, I cut you off there, but Sanaz, if you'd like to add to that, please do.
I was complete. So depending on the class of rehabilitation, or if we need it to be anti-corrosion only, semi-structural, full structural, we might need the system to be fully bonded or not bonded. So if it is fully structural system, we actually don't want the polymeric pipe to rely on the hose pipe. So we don't want it to be bonded. Surface preparation would be minimum because no bonding is needed. But for the cases that is corrosion prevention, we wanted to have a very good bonding. And in that case, we use very good surface preparation. We should have good surface profile, roughness matters. We use primers and then lining. So depending on the system, we're going to have different application steps. And the thing is that we don't use just one formulation, one type of product for all of these applications. So the products used for semi-structural, full structural, or corrosion prevention only would be different. The chemistries are similar, but as you see, application steps, thicknesses, surface preparation, and product formulation would be different. So because the properties that we need would be different for each case.
There's another group of questions that are asking about the finite analysis and whether or not you factor in long-term creep resolve.
Yes, we use FEM, and we apply the creep retention, and also we apply the safety factor. So after applying both of those, we design the system. And so the thickness that is proposed is the thickness for 50 years of design life after creep retention, creep reduction actually, and also applying safety factors.
A question has come up: will the lining survive in the instance where the hose pipe fractures or ruptures?
Yes, so for full structural design, we imagine the worst case scenario, which we don't have the hose pipe. So we ignore the presence of the hose pipe. When the hose pipe fails, the new polymeric pipe would stay there. That's why we don't want it to be bonded. We don't want it to rely on the hose pipe. So if something happens to the hose pipe, the new polymeric pipe would be able to stand there and have a lifetime of minimum 50 years. But for semi-structural bonded and also for corrosion prevention, they still rely on the hose pipe. So if something happens to the pipe, a fracture happens to the pipe, they would fail as well. The only thing that I can say here is that if we have a hole, like a corrosion hole inside the pipe for class 2 semi-structural, the system has the capacity to span those holes and gaps to some extent. But if it is a fracture or pipe failure, no, it would rely on the hose pipe and it would fail as well.
Could this be used for joint repair without lining the entire pipe?
Yes, with when we do it for like sectional repair, we need to make sure that we get enough bonding. So if I cannot tell you that we can do one segment without bonding, we need to make sure that terminations are fully bonded. It is important where we terminate. The surface preparation is important. And if you are doing this repair on a crack, or is it on an expansion joint or whatever, so depending on those, the system might be different. So yes, it is possible, but we really don't suggest that we use this SIPP, which is good for pipe rehabilitation, pipe renewal, for segmental repair only. But yes, it is possible.
Are there additives or products that can address high or low pH or provide chemical resistance?
Yes, so we have done the pickle jar test based on Green Book and also SWOT test. These are mainly for wastewater and sewer applications, which we are dealing with acidic materials. So the product has passed those tests. yes, we have some options for the cases that we have lower pHs. Mainly lower pHs are the issue, but we have products for those too.
I think you may have answered this. What were the short and long-term creep results?
Creep, you mean flexural properties, flexural modulus? Because creep is, we do creep tests based on ASTM D2990 for, we do the test at constant loading for 10,000 hours, get the data from 0 to 10,000 hours, then extrapolate it for 50 years of design life because no one can wait that long. So that is the creep test that we do. So short-term properties, for example, short-term flexural modulus is 320,000, and the long-term 50 years would go to about 120,000.
I'm going to answer this question about whether or not it's for potable water lines. And yes, we do have potable water solutions that can work in this situation. Aiden, did you have a question that you had picked out?
No, not at this time. I see a lot of them are going ask me about moisture, as well as asking about diameters to be completed. I believe we already addressed the moisture concern verbally. As for diameters that can be completed, our current robotic units, so unmanned application, can be used in diameters of 3 inches up to 172 inches. Anything larger can be applied manually. So theoretically, there's no maximum limit, but the minimum would be 3 inches.
Also, someone asked about difference between polyurethane and polyurea. So they both have isocyanate. One has polyol, and the other one has polyamine. So polyurea has polyamine, and the reaction between polyamine and isocyanate is very fast. So that's why the gel time and drying time of polyurea is faster than polyurethane. And polyurea is not sensitive to moisture because of this fast reaction. OH or water doesn't find time to start reaction with iso. But for slower gel polyurethanes, they are usually more sensitive to moisture.
One of the other questions was, what about pipes with sags in them?
Like pipe displacement?
Yeah.
Okay, so we need to see those. So projects are different. We cannot have one solution for every project. In some cases, can be repaired, or we can lift the pipe up or do some repairs. In some, it's not possible. That's why we always say that we need to do the pipe rehabilitation or renewal before it is too late to do so. If the pipe has already failed, if it has already collapsed, there is no way that we can take care of it. But if it is near to that stage, we still have some time to take care of it. So depending on the condition, we might have some procedures to actually solve this issue and apply the liner. So we have done similar systems before.
There seem to be a few questions that address how we determined our 50-year design life.
Okay, so as mentioned before, one of the very important tests is the creep test based on ASTM D2990. It gives us the long-term properties. So no one should use the short-term properties to design the pipe, polymeric pipe, which is going to last for 50 years. all materials, including polymers, they go through creep. So their properties, their numbers, their structural strength would be changed over time. That's why we do this test for 10,000 hours. Then we extrapolate the numbers to give us the number for 50 years. And we use those 50 years numbers to do the design. So the numbers that we enter in our equations or models would be those numbers. So we usually say that we apply the creep retention and get the required thickness.
There's another question that is asking about the design thickness in arch-shaped culverts and whether or not the design thickness is dependent upon how far the surface is from the spray unit.
So for the arch pipes, we usually model the pipe using Abacus or SAPP or use Candy. We usually don't get very accurate numbers from F1216 because it's mainly for circular pipes. So we use those, and the design thickness depends on the condition of the pipe, if it is fully deteriorated or partially deteriorated, the depth of bury, if it is under roadway, railroad, so that the traffic actually or live load, the hydrostatic load, which depends on the groundwater level, and for culverts mainly that's it. So if it is a pressure pipe, we need to consider the internal pressures as well.
Have you done any testing for abrasion resistance?
Yes, a lot. So we have some products that their abrasion resistance have been tested and compared with carbide or stainless steel. They provide much higher abrasion resistance, and we use those systems in mining industry, which we have the maximum abrasion and wear. So yes, different products have been tested for abrasion, and there are different tests for abrasion actually. One of the most popular one is we do it based on CS17 1000 rounds, and the milligram loss is reported. So we weight the sample first, we put it under abrasion. After 1000 cycles, redo the weighting and see what was the milligram weight loss, and the lower would be the better. So we have some materials that have like 1 milligram loss, some of them about like 45, 50 milligram loss, but all of them very good abrasion resistance.
There are a lot of questions regarding how much moisture can be present for us to apply. So in essence, like how dry is dry, or how moist can it be?
Yes. So again, depending on the system that we apply, if we want it to be bonded or not, it is different. The thing is that we should not have any standing water, any flowing water. And the dew point matters a lot. So we need to check the environmental condition, the environmental like ambient temperature and surface temperature. And we should not apply the system if the surface temperature is lower than 5 degrees Fahrenheit over the dew point. So the humidity in the environment matters a lot. Humidity on the surface, if the surface is damp, we usually apply a pure polyurea first, which is not sensitive to moisture at all. It doesn't react with water. So that is why I say that the system can be different depending on the condition of the project. So we have solutions for that. We can use vapor barrier primers or vapor insensitive primers, or also pure polyurea, which wouldn't react with moisture.
Question from our friends in the United States. What is the fire resistance of the cured material?
So we have done UL test, but usually for inside the pipe, no one asks us for fire resistance, but these systems do fire distinguish. So if there is a flame on them or they burn, they gotta distinguish themselves. They are not considered as fire resistance, or they cannot protect themselves against fire. So those technology is those are different, not like this. But we have done some tests. So if you're interested, we can share those data too.
There's another couple of questions that ask about spraying on top of existing liners or other technologies.
Okay, so if we want the system to be fully bonded, we need to check the condition of the existing coating, the old coating. So we need to make sure that we remove all the loose parts. And if the old coating is not in a good shape, that needs to be removed. If the adhesion of the old coating is good enough to the substrate, then we need to check the bonding between our new liner and old coating. So we have some intercoat primers that can activate the old coatings, and we can get good bonding. Depending on the type of old coating, it might be coal tar, it might be bitumen, it might be epoxy, it is different. So if it is bitumen, I say we cannot provide bonding. If it is epoxy, we say that, yes, we can provide bonding. This is the intercoat primer that we recommend. So it matters that what is the type of the old coating and what is the condition and bonding strength of the old coating.
I'm rewording this question, which is basically asking, do our design thicknesses come in about the same, more or less than a CIPP design thickness?
I really cannot compare these. I really cannot compare these. So in some cases higher, in some cases lower. In general, CIPP would be more expensive or less competitive in larger pipes. So in larger pipes, or thickness or the total cost would be lower than CIPP.
Sorry, I'm reading one that just came in. Basically, they're asking how we compare to other plastic materials, like thermoplastic materials or plastic-based material.
This system can be classified as plastic polymers. So the properties are close enough to plastics. We usually compare our properties or follow the tests that are addressed for PVC or HDPE. So these are kind of role models, so very close.
Could the various methods, structural, semi-structural, corrosion only, be applied to vertical infrastructure such as sumps, wells, lift stations, manholes, or catch basins,
yes,
in addition to the linear pipe infrastructure?
Yes, yeah, all of the above. It can be applied in the vertical structures.
And this is what Empipe does. Is dehumidification required for application in some instances?
Yes. Yes, in many cases it is needed, yes. Dehumidification is important because of that dew point that we already talked about. So the humidity in the environment.
There's a question regarding removing bitumen coatings before SIPP. which
Okay, so
I think we'll answer that one offline because that's an application question that we can probably handle. But yeah. Oh, some people leaving. Are the products UL FM approved for lining of underground fire water pipes?
FM approved?
Yeah.
We haven't done any specific tests for that.
Okay. Actually, we're coming up on 2 o'clock Eastern Standard Time. So we will have to end the session. There are a number of questions that we'll be answering directly to you, to your emails. Again, I want to thank you guys for joining us today, and Empipe as the sponsor. Everything that you saw in this presentation is what Empipe does. So if you are looking for more information on how this is applied, please reach out to us, www.empipe.com. Thank you very much. Thank you very much, Sanaz, for your presentation and all the information. Thank you, Aidan, for joining in and answering some of the questions. And we'll see you next event on April 20th, Microtechnology for Utility Installation. Thank you very much, everyone, and have a great day.
Thank you for your time. Have a good one.